day anyway. All right, I'm actually still stuck at the office here, and I would be going till about maybe after 7, right? I could probably try to finish about maybe a couple minutes early, but I'd have enough work to go straight to half 7, right? For those who don't know, we normally have classes in the night. We actually do have I have class every Monday, every Tuesday for the last 4 to 5 years now anyway, right? I am kind of used to it, but you all may not be used to it. With that said, let's start, right? So the objective of this session, we would have covered this on Sunday, but maybe I can go back to that first slide, right? And let me go back to that first slide so you can see where we were at then, right? So we are somewhere wrong. Explain the hazards inherent in the oil and gas arising from the extraction, storage, and processing of raw materials and products. The first half an hour of the class, I am kind of fighting a bit of the cough. So if you hear me kind of slowing down a bit, it's because of that, right? But I have taken off the AC. The AC kind of makes it a bit worse. So let's hope it kind of settles itself out, right? I think we were right or wrong here. We did that one. We did that one. We did this one. I think we can take it from hazardous properties of water, right? Some nice sessions tonight. When the rest come in, I'll kind of address you on maybe a bit around 7 o'clock because it don't make sense making any sort of comments this early then because not everybody is here, right? Hazardous properties of water. So water exists on three states, liquid, I think I read this slide too, right? Solid ice and gas steam. It is used extensively in the oil and gas industry processes. Uses include for water, cooling, lubrication, drilling mud. And drilling mud is actually used as a lubricant on some equipment. It's a source of water in the case of a fire, steam, power turbines to generate electric power, to drive pumps, compressors, fan, and other equipment. Heating source, control rooms, tank, coil, and trace heating. So, properties of saturated and superheated steam. Saturated steam is an excellent heat source, particularly at temperatures of 212 degrees Fahrenheit or 100 degrees Celsius and higher, and has the following advantage. Improve product quality and productivity. Temperature can be quickly and precisely established because the temperature is actually 100, right? It's 100 degrees Celsius. The smaller required heat transfer surface area, enabling reduced initial equipment outlay, rapid even heating through latent heat transfer, safe, clean, and low cost. Saturated steam has three main disadvantages in a steam engine. It contains a small droplet of water, which have to be periodically drained from the cylinders. It inevitably condenses to some extent in the steam pipes and cylinders outside the boiler, causing a disproportionate loss of steam volume as it does so. It places a heavy demand on the boiler because a large amount of water has to be evaporated per unit volume of steam. Um, just at the most basic level there, saturated steam is actually the steam you get when you boil water at home. If anybody wants to paraphrase some of these, just to understand the differences between them, beheading is saturated and superheated. Saturated steam is the one you get when you make, tea tonight and or coffee or whatever have you, right? That type of steam, if you were to raise your kettle cover, or if you have, I guess, an electric kettle anyway, but to look just under where the 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 cap is there, right? You would see water, right? So saturated steam has a mixture of steam because you'll be seeing steam, you'll be seeing the vapors of water boiling, but it also has water droplets in it, right? Saturated steam again has a mix of steam and water in it, and the water poses a hazard then. It poses a hazard then in terms of initiating things like corrosion, developing scale, right, on your metal surfaces. And for some of them, you're seeing a bit that it does actually lean to where you have a bacteria that tends to grow in warm waters. So saturated steam is kind of, perfect for that as well, right? The other type of steam, let me read out a couple of slides and explain it. So superheated steam is steam at a temperature that is higher than its vaporizing boiling point at the absolute pressure. I'll explain that in the end. It is a steam which is formed at a temperature which exceeds that of saturated steam at the same pressure. Well, that kind of said it, right? So at 100 degrees Celsius, what you get is saturated steam. And if you cross 100 degrees Celsius, which you wouldn't cross normally, like if you're boiling water, right? Now you could get it, but I did say normal, right? Like if you're boiling water in your stove, it will just reach 100 degrees Celsius, right? Now you can get it to um over 100, and which is start to get superheated steam now. But you're gonna have to like apply another heat source, right? So if you have like a blowtorch, some chefs, there's actually like a version of that for chefs. So if you have like a blowtorch, like a chef blowtorch, and you apply that to like your kettle, it's gonna cause the water because your normal oven is gonna carry it to 100, right? Unless if you use some kind of pressure oven or so, right? But if you keep on heating that kettle then, but when I say keep on, you have to add another heat source. You just can't keep the stove running because it'll just keep at 100 degrees Celsius, right? If you have another heat source like a blowtorch and you keep that flame then onto your kettle, it's going to cross 100. And what you're going to see, you will stop seeing the steam. I don't know if you want to take a note of that. So you'll stop seeing the steam. So how do you know it's there? The answer is that you don't know. Superheated steam, you cannot see it, right? It is a steam that is formed at a temperature which exceeds that of saturated steam. What makes you see saturated steam or boiling water steam is the fact that it didn't have water in it and you can see the vapor. But at the stage of superheated steam, you don't have a vapor. It's actually invisible, right? If you had if you had as well, again, this is for the oil and gas industry, but if there's a steam line, at superheated steam, you wouldn't see the steam, which is a big hazard because a worker could actually, like, you may feel the heat because it's over 100, so I don't think any worker could walk into it. But at the same time, you cannot see it, right? So somebody that may be in a vehicle then and probably not feeling the heat may actually drive a vehicle into that steam line where the steam could have been gushing out. But if it's at superheated steam, you cannot see it, right? So there's some hazards associated with that. Of course, some uses too. So the superheated steam is using turbines to improve thermal efficiency. Others include surface technologies, cleaning technologies, catalyst work, chemical reaction processing, surface drying technologies, because superheated steam is actually dry. You could actually you can put a sheet of paper in it. Like if this is a hose, a pipe, and superheated steam will come out, you can put a paper in it. The paper wouldn't get wet because remember it's actually beyond 100, right? Beyond 100 degrees Celsius. In fact, what would happen? The paper will catch a fire. So if you have superheated steam, being dispensed from a pipeline and you have vegetation, which is what we have in the Caribbean here. If that vegetation was dry, it's going to catch a fire and result in probably a catastrophe because that steam itself could actually lead back into some gas chamber that may, result in some kind of explosion, right? So current technologies, soil steaming, energy systems, nanotechnologies, all of these, superheated steam could be used in it because catalysts, nanotechnologies, the superheated steam is not wetting it, it's cleaning it, right? It's not wetting the surface of it. So what are some hazards? We have thermal expansion. They sometimes use steam to clean a tank, but then it steams, it may cause the metal to expand, joints, bolts, whatever have you. If they were constantly doing that tank, may have shifted and may have expanded a bit, right? And it, of course, if it's a metal, it's going to result in some kind of leak or whatever have you. Formation of vacuums, what they say if you use steam to clean a tank or any confined space then, like a pipeline, if they withdraw the steam suddenly, it could create a vacuum and that may suck the metal into itself. Tanks have crumbled like that. But again, I guess most people know now not to withdraw the steam then. If you have, like a contractor, you have someone that is actually superheating the steam and getting it into the tank. You have machines for that, right? In the catalyst world, we have machines for that. right? Vacuums, they call it. They actually refer to it as a vacuum truck or a vacuum pump or whatever, right? But we all know now, like not to withdraw the steam suddenly because it could cause the metal of the tank to crumble upon itself, right? Other than that, if we go back to the other kind of steam, the one with the water in it, water in steam lines can result in something called a water hammer. You all must have heard it. We actually hear it sometimes if you look at your water company. We have somebody from Guyana here, so not just WASA. WASA is, of course, Trinidad and Tobago Water Company. But if you look at if we look at like when the pressure is hard in the pipe, then you can sometimes hear the water knocking in the line. And if you've been in the oil and gas industry, that's a normal thing. That's a normal thing on a pipe rack. If you know what a pipe rack is, a rack of pipes, that's a normal thing when you have oil running in it. You have that. And of course, oil is not just oil for those who know. Oil is a mixture of oil and water. When we say oil in the oil industry, it's oil and water, right? So you are going to get that vibration in the pipe, and if it's around colors and joints, it's going to cause like a knock. They call that like a water hammer, right? That could result in like joints, colors, being weakened, and of course it could result in some sort of leak, right? So water and steam line, water hammer. Water hammer is the unexpected release and associated shock wave of high pressure steam condensate. It can cause death if, of course, there's a leak, severe injury or extensive property damage. Scalding because all of these steam is hot, 100 and above, serious physical injury. Right? Okay, yeah, good night there, everybody, right? So I think I just mentioned the vacuum, right? So vacuum formation during drilling operation, hydrostatic testing. Wait, let's have a read of this. A hydrostatic test is a way in which pressure vessels, such as pipelines, plumbing, gas cylinders, boilers, and fuel tanks can be tested for strength and leaks. The tests involve filling the vessel of or pipe system with a liquid, usually water, which may be dyed to aid in a visual leak detection, and pressurization of the vessel to the specified test pressure. So the heading here is water hazard. So you can actually use water for testing like a line. If you know, maybe a line would have been modified, pipeline, if you know what I'm talking about. So maybe you change a piece of it because of a leak, but they want to put it back on. The truth is, if it's on a pipe rack, they would just put it back on. But if it was an isolated piece of line, or probably maybe like some sort of condenser, nothing that is, like hundreds of feet in length anyway, right? What you could do, you could pressure test it with water, and they do that with tanks, right? Like before, again, if a tank was clean, modified, welded, painted, whatever have you, right? Um, just um just before putting it back into service, if it was oil going into that, they would have pressure tested it in water. Those of us in Trinidad here, we had an accident like that down at the company that, of course, formerly known as Trinma. But you all remember that they pressure tested a tank, and it resulted in a huge, well, the tank gave way a huge sort of farm tank, and it resulted in flood. It was like flooding conditions in that part. If you know where Trinma was, it's a series of hills like that anyway. So it flooded the whole area anyway, right? So not nothing is wrong with that sense in using now water. I think water is a good agent to use because it's just water. Testing any modified pipework, cylinders, tanks, etc. I think water is used there, and that's something called a hydrostatic test. Is a way to test the vessel for its integrity. You put it under pressure, right? Increase the pressure of it anyway to make sure the tank could hold or the vessel could hold, and that is what is called hydrostatic testing. Yes, Imara?
Hi, good day, sir. Good day, everyone. I just wanted to make sure you're reading from something or you're sharing the screen. I'm not seeing the screen. I saw someone as well in the chat asking if you're sharing something.
Of course I am. So thanks for mentioning it, right? I just tell me when you all can see it. It is the same lesson from Sunday. Can you all see it now? No? That's weird. Okay, just let me see what's happening. Let me stop with
No,
the
I'm
show
not seeing
altogether.
anything on my end.
But that's why thanks for mentioning that, the way thing is that the class would have gone on and nobody would have said anything. I had a class like that, my diploma students are like that. But then they have the PowerPoint, so maybe, I don't know, maybe they thought it was okay. But I had a class like that, and then at the end of the class, I looking back at the recording and I'm not seeing the video showing. I was like, a whole hour and a half class, right? Nobody said
All
anything.
right,
Can you all see
seeing
it
it
now?
on my end.
Yes, okay, good. Right.
Great. Thanks,
Just
sir.
to say. Yeah, but it's the same PowerPoint we actually just picked it up right from where we left off on Sunday, right? And whenever you see that, please mention it. What happens? The Zoom is like that. Like I was seated, but you all can't see it, right? So sometimes if you're not, once you see we here, we reading from something, right? Is either the book, if we read it from the book, when the book come, I will let you know. Right? And if it's not that we're reading from the PowerPoint, you could print out your PowerPoint, you could have it. Like I said, maybe that class, that was a degree class, maybe they felt as if, but they know that's not the norm. They know that's not the norm that I wouldn't share what I'm reading from, right? But like I said, when looking back at the recording, I was like, wait now, I hear the thing, right? The class had more than 25 people in it, and none of them said anything, right? That's the strangest thing ever I told them, right? Anyway, thanks for sharing, right? Okay, let's go again. So, water hazards and associated controls. So, coolant towers or coolant tower areas, heat rejection devices that reject waste into the atmosphere through the cooling of a water steam to a lower temperature. Typical hazards can include, and this was saying, like wherever you have like a condenser, where you have, like a heated system. I don't know if you know what these things are, condensers. You get like vapor or water droplets, like back in the day, right? When I was in uh Petrotrin, for those of us who know, right? We never really studied those things as hazard. We used to play with those things, like play in the water from the condensers and then, but only now, of course, you realize that these things were hazardous, right? So typical hazards can include Legionella and water vapor fog. This is actually like caused by two bacteria. Legionellosis is a collective term of diseases caused by the Legionella bacteria, including the most serious Legionnaire's disease. And I might read this and not tell you about that just now, right? Outbreak of the illness occurs from exposure to the Legionella growing in purpose-built systems where water is maintained at a temperature enough to encourage growth. And that's about 25 degrees Celsius. You see it on the slide just now, right? Example, cooling towers, evaporated condensers, hot and cold water systems. So Legionnaire's disease, fatal. That's the simplest way to say, right? If you look up Legionnaire's disease, the symptoms is like COVID. It's the same thing. It's cough, cold, but the downside of the normal cough and cold, it affects your lungs, right? Like how COVID had affected your lungs. So Legionnaire's disease is fatal if you don't get. But of course, the good thing here, for those who know, this is caused by a bacteria. Anybody knows what is good about that? COVID is caused by a virus. What is good? I mean, it's a bad thing. It's a fatal disease, right? So kind of luck and chance that they recover. But what's good about it that it's caused by bacteria? Anybody knows?
So,
Antibiotics.
Very good. Yes, antibiotic, right? So antibiotics, Michael, how was it? Michael was saying it? Yeah. Yeah. So that's a good thing. Like antibiotics would work on it. But COVID, remember, COVID, they treated your lungs, they treated with antibiotics. But then you see the cause wasn't a bacteria. And antibiotics have no effect on viruses. Don't know if you know that. But it's very effective on bacteria. For now, anyway, for now. For now, you can do the research on that, right? Researchers are saying that, of course, the Black Plague, or the Black Death, as they call it, was really caused by bacteria. Bacteria do mutate, and they were saying that these bacteria are mutating, so the antibiotics may not be too effective of them or on them in the future. Let's hope we're not around, but again, our kids would be around, so somebody would have to face that in the future, right? I was telling you all about the condition and the temperature, right? Certain conditions increase the risk from Legionella if the water temperature in all or some parts of the system may be between 20 to 55 degrees Celsius, which is suitable for that bacteria growth. It is possible for breathable water droplets to be created and dispersed, example, aerosols created by a coolant tower or water outlets. Water is stored and or recirculated, and of course, if you have that, you can get the water droplets. If it's a bit like in this temperature range, it's not as if the bacteria will always be there, but it could be there. It's kind of like rats. Yes, rats, right? Remember, there's another disease. This one is Legionellosis, but there's one called leptospirosis. Now, that bacteria is found in the urine of rats, but not all rats, right? So, like, not because you have rats, it means that you'll get, like leptospirosis, but the chances are the bacteria does live in the urine of those rats. But, everything, I guess happens, I guess, for a reason anyway, right? So not every water this temperature then would have Legionnaires bacteria, but then the bacteria love to live in temperatures like that then, right? So cooling towers, condensers, spa, yes, a spa, a sauna, all of those systems that people like to go and relax in as well. The bacteria loves to live in that sort of temperature anyway, right? All right, mercaptans. Mercaptans are a group of sulfur-containing organic chemical substances. They smell like rotten cabbage. If mercaptans are in the air, even at low concentrations, they are very noticeable. Pulp mills are the chief source of mercaptans. They are found in the production processes of petroleum products. So, have a couple more on it, right? Just a couple more slides. So they are also used as an odorizing agent in natural gas, LNG. The human body produces them naturally during the digestion of beer, garlic, and other foods. The vapor, if inhaled, may cause headaches, nausea, dizziness, drowsiness, and a loss of consciousness. They may also be irritating to the eyes, respiratory system, and the skin. Mercaptan's the Milan incident in 2004, an exhausted mercaptan canister used by a natural gas distributor was being returned to a supplier for refilling, so it was empty. The canister sprang a leak while in transit at a road delivery company in Sesto San Giovanni, a town just north of Milan, Italy. Gas was carried by wind across the eastern half of the city of Milan, causing residents as far as 12 kilometers from the canister to make thousands of calls that overwhelmed emergency services for 4 hours and risk hiding actual gas leaks, right? So, um, long story short, if you all don't know, just a long story short, they normally would add like one of these gases to the gas tank you have at home, to the propane tank at home, because propane itself doesn't have a smell. So, like when you're home and like you're changing your gas tank, or God forbid, God really forbid that you have some kind of leak, what you're smelling is actually not propane. Propane don't really have a smell. What they added it is like a odorizer. They add like a mercaptan. So like if you're smelling that, just okay, you're smelling gas. But I mean, it is a gas you're smelling because mercaptan is a gas, but it's not really propane you're smelling. Propane don't have a smell. Think you understand that a bit? That's a simple thing. It's not hard to figure out, right? Drilling mud, right? Used in the oil and gas drilling process and referred to as drilling mud. The main function of drilling mud includes providing hydrostatic pressure to prevent formation fluids from entering into the well bore, keeping the drill bit cool and clean during drilling, carrying out drill cuttings, suspending the drill cuttings while drilling is paused, and when the drilling assembly is brought in and out of the hole. Types of drilling fluid includes water-based, gaseous-based, and synthetic. Most companies just prefer mud anyway, right? Water-based mud is the most frequently used. The drilling fuel used for a particular job is selected to avoid the formation of damage and to limit corrosion. LSAs, low, right? Specific activity material sludge, right? Is composed of dissolved solids which precipitate from produced water as its temperature and pressure change. Sludge generally consists of oily, loose materials, often containing silica compounds, and may also contain a large amount of barium. Dried sludge with a low oil content looks and feels similar to soil. You may have seen this, those of us in Trinidad, those of us in Guyana. Now, you may have seen this. They are found, in abandoned wells. They are found in, if you clean out a tank that contain oil. This is a normal thing in the company. We call it BS, which you know what that stands for, but the proper name is actually sludge. Again, contractors, if you're cleaning out a tank that was containing oil, remember oil is not just oil but oil, water, and I guess some sort of silica as well. So if you're cleaning that out, I remember doing it, right? I told you back in the day I worked with a contractor. They would, of course, ventilate the tank, but the way you clean it, is with a shovel. There really isn't any other way, right? So a shovel and a wheelbarrow and you're cleaning all the sludge, from the tank anyway. I suppose there may be some sort of high pressure testing or washing, but then the sludge is going to wash down somewhere. So the parts that are solid like soil, you kind of have to get a shovel into that to kind of get it out of there anyway, right? And then you could wash at the base of it, right? One time, just a funny story here. One time I actually fell into a pit that looked as if it had soil. It looked solid because it is dry and it looks like if it's dried, it looks as if it's solid, but it's just on top. And I fell into a pit with sludge in it anyway, right? All right. Sludge at low specific activity, LSA material. So sludge contains radium, all of these things, barium, radium, are radioactive stuff, right? Although the concentration of radiation is lower in sludges than in scales, sludges are more soluble and therefore many could dissolve in water and more readily released to the environment. As a result, they pose a greater risk of exposure. The concentration of lead is usually relatively low in sludge. Sludge is often found in shale shakers, separators, crude oil tanks, and wellheads. And my experience is in the oil tanks. I suppose wellhead too, because I guess the wellhead normally have a connecting drain to like a pit at the end of the location anyway. All right, question here. Following a preparation of a vessel for maintenance within the oil and gas installation, a low specific activity radioactive sludge was encountered, which is just sludge. That's what it is, right? Because it's a thing, right? So identify hazards associated with this sludge. You can talk about things like ill health effects. In itself, it is an ill health effect, right? It could cause irritation, but it could go to the radiation part of it. Outline 4 control measures to reduce the risk to workers. You can talk about proper PPE, proper ventilation, maybe using some sort of mechanical arm, as I had mentioned, using a shovel. Maybe they could use something better today, but I still know they had a sludge. You can't get rid of it anyway. If that tank has been, resting for a while, you have to put a shovel to it, right? Identify 2 other pieces of workplace equipment where the sludge may be found, right? So they mentioned a tank here. You could probably go to the wellhead or maybe some sort of collection pit wherever you have oil and water settling or gathering. If it is like a holding pit, like a bond, BUND, you'll find sludge inside there, right? So not to take up your time, I'm seeing 6:26. I did have some people that attempted the question from Sunday. However, what I want to urge you all, I said it and I listened back the video because I know you'll ask for the video. I put it on YouTube this evening. I actually listened back to the video. I fell asleep listening to it, by the way. Yeah, I fell asleep. Like if you want to sleep, for those who can't sleep, just to let you know, just put on one of my videos and you'll sleep really good, right? I know this is really true because I say it for myself too, right? Yeah, I knock out, I knock to the office there, right? I knock out the office. Anyway, but I listened to it, right? And I remember telling you all the meaning of the verbs now, right? Outline mean you have to write 2 to 3 lines. So from the homework I got, I realized it was like 1 line. You could give a 1 line for identify, but you cannot give a one line for outline. Like if it was outlining the control measure of, like let's just go to a simple, like a control measure is having a permit to work. But you need to write about 2, 3 lines on that. So it's like a control measure is permit to work. The tank would have had to be isolated, meaning the oil supply would have had to be closed off. The tank would have had to be proper ventilated, and you probably should have a proper emergency team standing by in the event of any, breathing difficulty encountered by the contracted workers who are going in to clean the tank. So that itself could have been about 2 to 3 lines, right? But they cannot give 1 line, they wouldn't give the mark. And then when they say identify 2 pieces of workplace equipment, identify is not a word. Identify is a sentence. They say a piece of work equipment is a collection pit or bond that was previously used or that is currently being used to store oil, not really gas, right? Oil, right? But you put it in a sentence, right? So outline 2 to 3 lines, identify 1 line. If you put a word, they wouldn't give you the mark. If you put the piece of equipment as a bond, BUND, you would not get the mark. Please take a note of the verbs, right? So I said it again in this lesson. We could have a look at it. And When you get a chance, I had about 4 people did assignments. When you get a chance, please get them done, send them in, because remember, there's a written exam at the end of this. NEBOSH is NEBOSH at the end of the day. And yes, we all like to say we have this. I listened back to the video, so I said all this in the video where we have this. You're already lucky, 18 people. We have six in Guyana. Well, in another batch, because at the end of the day, it's only 40 people going to hold a qualification in the region, right? But you had to study, and as much as you could, try to study from the slides. Your books have been ordered, they have not reached. I actually got process safety books, which was kind of weird, because I think I ordered all at the same time. Today is Wednesday, right? Process books came on Monday, but all the books were ordered at the same time. I'm not the delivery people. I don't know what happened, but it should be here tomorrow because DHL said the plane is flying on a Wednesday. So that means if it had anything else, I guess on that first delivery, it would have come into the country today. So we expect to get it. And you'll get your book. But please remember, what you see on the slide is what you see in the book. The slide is like a condensed version. When you start watching this book, you wouldn't know what to do. You can read, but then where do you really, where do you really zone down to? If you use the slide zones it down then, it zone down to what exactly you have to know then, right? And, as you see, I'm looking at some of the definition from last week. Well, this week, right? I'm looking at vapor density, right? All of those stuff, biocides. It just have one short thing on it there. I mean, all of these have like a short line, which is like the equivalent to what you see on the PowerPoint, right? So don't say you're waiting. Start one time. Start revising one time, right? I would be here on Saturday. I'm hoping your books come in. It should, based on what DHL said, and they can come and collect them, Friday, Saturday, once they come in. As soon as they come in and message the group, the process books came and nobody came to collect them. That's the other thing. But the book is yours. Remember, you paid for it. I wanted to have it. Your money is paid for it, right? And we ordered your books, like I said, about a week ago already anyway. All right. Hazards of inert gases. So below 11% oxygen, there's a risk of death due to asphyxia unless the person is resuscitated immediately. In general, oxygen deficiency can lead to loss of mental alertness, distortion of judgment, brain damage after a relatively short time. Hazards of inert gases. I guess that's what they're saying. The inert gases reduce the oxygen level, right? If we're okay with that, we could skip some of these. Hazards of inert gases causes difficulty in breathing, asphyxiation. Um, there's no warning sign, right? All of these temperatures and stuff, you're not really required to know it, but those are the features of the inert gases then, right? Like nitrogen, etc. All right, let's get into this one. Electricity is the next thing I'm seeing here. I would have loved to take you, through the pages anyway, but we'll just keep it going, right? Some really nice stuff coming up, but we'll take it anyway, right? All right, drilling mud. We just finished up drilling mud, right? All right, so electricity. We have here electric current is the amount of charge flowing through a conductor at any given time. Electric current I is measured in amperes. The greater the potential difference, which is voltage across, or the greater the voltage, the greater the current. That's what this means. Potential difference is voltage, right? So the greater the voltage, a 220 volt is more than a 110 volt, right? The electric or the electrical pressure, and they said it here, the electrical pressure which causes the current to flow is measured in volts or voltage, right? So the understanding here, if you want, the understanding is like water in a hose. If the hose is very thin, the water will come out at a higher pressure. Or if you increase the pressure again, right? But increasing the pressure is like increasing the voltage. The more voltage you have, the more current you have. That's what they're trying to say here. The greater the voltage across an electrical conductor, the greater the electrical pressure that influences the flow of charge. Flow of charge is current. Watch it up here. Flow of charge, charge flowing, charge flowing. So the greater the voltage, the greater the current. That just makes sense. Think about the washer, dryer you have at home. If you have a 220 AC unit, That's 220 volts. If you have, your normal sockets in Trinidad and Guyana, that's 110. So the greater the voltage, the greater the current. It really do have nothing else than that. There's a little formula for this. For those of us who know it, is V is equal to IR. These here are the transpose formula. This is something called Ohm's law. V is equal to IR. Voltage is equal to current by resistance. You do have different types of current, direct current, alternating current. Thinking if they'll give you all anything to work out, right? But you should probably remember V is equal to IR. I'll probably tell you commit that to memory. Commit V is equal to IR to memory, right? That's Ohm's law. What you're looking at up here is when they transpose the formula. But the real, like the main formula that is V is equal to IR. Voltage is equal to current by resistance. There's a way you could use it. From the past paper questions, I've never really seen they give you any to work out, but it have some working out it. If you want to do that, I can do one basic one. But I've never really seen. I mean, if they give you, right? If they give you voltage, anybody knows this? Somebody does it one time. If they give you the voltage, right, which they would, if they say, okay, our worker is exposed to 220 volts, right, which is like, AC units and stuff, right? So if they say the voltage is 220 volts and they give you the resistance, which resistance is also a constant. I don't know if you know that. The human body, according to the matrix, right, Morpheus, like human beings are like a battery then, and which we are. We have current flow in us when it's the end of life anyway, right? One of the ways, like the medical professionals who try to revive you is to charge you. They say charge and they try to put back that charge in your heart. So in essence, I'm not too sure if you know, the human body has a resistance of 10,000 ohms. This is actually a constant. So if you have these two and they tell you calculate the current or the effects of the current in the body, it's an easy thing to do. But I don't know if you all know how to do it. If you have these two, how do you find I? Do you divide or do you multiply? I is current, by the way. I is current, in case you don't know that.
Divide, sir.
Okay, what dividing by what? Which one going on top?
V divided by R.
Very good. V divided by, excellent, right? So we have some physics people in the house, I guess. However, I've lost my marker. Can't seem to get it back. It's very frustrating. Okay. So yeah, so exactly V over R. So you take the voltage and you can divide that. What you'll get the effects of the current in amperes. But there's a chart. There's a chart that shows you the effects of the current in the human body in milliamps. Right? To get it in milliamps, you're gonna have to multiply by, I think, 1,000, right? So for now, this is, anyway, you all do the math, right? This is 220 divided by 10,000. Whatever you get here, then multiply it back by 1,000 to get the answer. Now, the only reason you're doing this is because human beings, then, we are affected by the smallest amount of current. So there's a table, if I click down the slide, that shows you the smallest amount of current affecting a person. So you don't have to wait on a large amount of current affecting a person. You can use this table here. This is a constant table. All safety people have access to this table. This is like your table in the back of your text of your copybook, right? This doesn't change, right? Anybody studying current would actually know this table. This is on the HSC website. This is all over Google. So whatever you get, I don't know if you all divide it. If you divide it and you multiply, what you're going to get is actually 22. Anybody did it? If you divide by 10,000 and you multiply by 1,000, I believe. Actually not doing it, eh? So I don't know. But I know what you're supposed to end up, but the answer is supposed to end up with is 22. And then that now tells you like where you would fall. This table tells you where you would fall. So we'll fall here as a safety if you are doing a risk assessment to the effects of somebody making contact with a 220 volt. The answer will always be 22. You could take this tomorrow to your work because it's the same thing. 220 doesn't change. The human resistance doesn't change. Doesn't matter age, big, small, healthy, unhealthy. That's the charge in your heart then. That's the resistance of the human body, right? According to Morpheus, like I said, right? But it is a really truth. It's really not Morpheus. It's really physics and stuff involved there. So if you get 22, what happens? You see that we will fall somewhere here, which is the inability to let go of that, electric source. And there's a danger of asphyxiation. If you remain, it's a very good there for the person that work it out, multiply back by 1,000, and you see end up back with 22. right? Of course, if you remain in contact with the surface, what you would see is that the person, yeah, very good, right? Elizabeth, very good. And if the person remains, you could, like in Guyana, when, I mean, just this year, there was a mechanic that got electrocuted. His supervisor saw him, tried to got in contact with him, and also was electrocuted. I don't think the supervisor died, though, but I know the worker died, right? So you could get the person away, but you have to use like a non-conductor, like a broom or something, a broom with a wooden handle. If you ever get a PVC pipe or something, fine, you could get them away. But the longer they're there, it's going to increase the effect, remember, to your heart and whatever it could cause, burns and of course disruption to your heartbeat and heart rhythm, which may result in death, as what happened to the mechanic in Guyana, right? Yes, Nikisia, which is joining us from Guyana as well, from a company in Guyana. Yes, Nikisia.
Good
Hi,
night, sir.
my good friend. Yeah. I'm coming across next week. I don't know if you know, not next week, the other week. Coming
Oh no, I
across. Yeah,
don't
the
know.
third. Yes. Yeah.
Oh,
Okay,
okay.
good. Yes, Nikisia,
So
go ahead.
on that same note of electrocution, there was actually an incident where an Exxon rep, she was electrocuted in her home. Her dog was chewing on a live wire that was in the ground. The wire wasn't grounded. So she went to help the dog and then she ended up dying. Her and the
Wow.
dog. Yeah,
Wow.
so
And
that happened like about
imagine.
a month ago.
Wow, okay. And imagine, well, I mean, and so that's the same company with I mean, that's the same Exxon with Devon and all these students of mine.
Yes.
Yeah,
Yes.
okay, right. Okay. All right. I mean, and that if it's at home, but that's actually 110. 110 should pin you somewhere here. But again, if the person remains in contact and like what it says that the effects of current, if you read this line, it's like different for different people. Like a healthy person may get a 110 shock and survive, but it all depends on like if your family have a history of heart problems or like your health and stuff. They say it's a phenomenon. Like it's a phenomenon, meaning like it's like if you get shocked, there are some people that survive and there are some people that doesn't survive. They say the pathway of the current is different and it's kind of unpredictable. For some people, you can get a shock here and the current come through the next part of your hand. They call it the entry and the exit wound. But then there are some people who make contact with the wires and the current flow through their heart. That's what they call it a phenomenon. It's not, current is unpredictable then, right? And it may have to do something with your health because for those of us who know the human body is a mix of salts and water. Your nervous system is actually electricity as well, or like electrical wires, but it is unknown. Scientists are not too sure why some people, like the current would just shock them here and come to the other side, but there's some people it goes to your heart, it goes to the vital organs anyway, right? So the electric shock factors influencing the severity of an electric shock is the voltage. The higher the voltage, the worse the consequences. You can see that from here. The lower the voltage, the lower the current, right? So, and in some cases, you just get the idea that, like you get shocked, but it pull away your hand, right? Frequency, which is how often you expose, to that current source. Duration, the longer, you are in contact with it, the worse it is for you. Resistance, if you are, and with full PPE, if you have, some sort of insulated, foot material on, the current pathway they say is, difficult. It's a phenomenon. It's not predictable as to how the current would actually enter and leave your body, right? Whether or not it's AC or DC also have an effect, right? Electrostatic charges, I mean, I think I finished off with the formula. Could clean it if you want, or I can leave it there if anybody taking it down still, right? But thanks to Elizabeth for working out those figures for us. Let me just kind of take this one off, right? I'll read and explain, right? Let me read out flush first, and then I can explain because the explanation here is pretty simple at the same time, right? So the sparks associated with static electricity is caused by electrostatic discharge or simply static discharge. I'll explain at the end. As excess charge is neutralized by a flow of charges from or to the surroundings. I'll explain that in a bit, right? Static electricity is generated when there's an excess or deficiency of electrons on the surface of materials. Discharge of static electricity can create severe hazards in the process industry dealing with flammable substances, where a small electrical spark might ignite explosive mixes. Yes, two of the chapters in this course is headed up as process safety. but not the same kind of process safety, right? A bit more to the oil and gas anyway. Some of us would have done process safety here, right? So you'd see some commonalities in terms of what the hydrocarbons, process safety 2. So if you feel I'm making it up. So there's actually process safety 1. But I'm showing you this one. These are open to the book now, right? So you'll find there's some kind of similarity here to some things when you see process safety here. But that's because 2 of the units cover the oil and gas approach, the process safety, but the oil and gas approach of that anyway, right? Anyway, let me see if there's one more here on static electricity, and I would explain, right? What am I doing? I think I have to clear this marker thing, right? To get our slide to move again. All right, so materials are made of atoms that are normally electrically neutral because they contain an equal number of positive charges, protons in their nuclei, and negative charges, electrons in their shells surrounding the nucleus. So some hardcore chemistry there, right? The phenomenon of static electricity requires a separation of positive and negative charges. When 2 materials are in contact, electrons will move from one material to the other, which leaves an excess of positive charge on one material and an equal negative charge on the other. When the materials are separated, they retain this charge imbalance. The ways to avoid that is bonding and grounding, but I probably need to explain back what we were looking at there anyway, right? So let me just go back and explain that a bit. Just quickly, not too long, right? But just the phenomenon of static electricity. So just to get the basic idea down, static electricity is called static electricity because the current doesn't flow. Like the current we looked at before, like the current in your wall socket then, that's normal current, it's a flow of charge. But static electricity doesn't flow. At least it doesn't flow naturally, right? So the charge builds up then. Just a long story there for those of us who know the structure of the atom. You have the nuclei and you have the shells around the nuclei. Well, it doesn't look like that. It's a complete circle, right? Inside there you have protons, and protons are positively charged. Electrons are negatively charged. So you have electrons floating around the protons. And it's not one. I mean, I think the least you could have is 2, right? It's not like one. I just draw one anyway, right? So what they say is that you have an equal number of protons and electrons, and that is said to be a stable atom. But life as it would be is not always stable, right? And what they say is that by nature, then some atoms don't stay stable. They tend to become unstable. And when they become unstable, they would either like lose an electron, right? Well, it's more about electrons, right? So like if they lose an electron, they become more positive. And if they gain an electron, they become more negative. You can have 8 electrons on the outside here, by the way. How they found it to be, you have 8 electrons surrounding, and you have different layers of electrons, which are referred to as a shell. If you see the word shell on the slide, right? So protons are found to be like in a cluster, and then around the protons, right? Now it's drawn like this, but in nature it's not right. It's like if you see a line, right? But you have around the protons, and you have electrons, and they are found to be 8 of them. I just draw 4, right? But the point I'm trying to say is that if the atom gains more electrons, it becomes negatively charged. And what they say, that is what static electricity is. Like when you take, I guess, a pen, and if you rub it on your clothes, what that does, that causes the atoms then in the pen and on your clothes to become unstable, right? So you'll have like your clothes, if it's like a coverall, will become negatively charged. And this is why they say it's static electricity. It's just like a collection of charge. It doesn't flow, then it builds up on your clothes. It builds up on your coverall, right? Anybody remember like when you were in primary school, or if you have kids, you'll see primary school children taking like a pen. I don't know, you could do it at a balloon too. If you have a birthday party, you could take a balloon and rub it on your clothes. Some people rub it on their hair. That act of that is aggressive for the balloon dance. It causes the atoms in the balloon, to become unstable. In some cases, it picks up a negative charge, right, from your clothes or from your hair, whatever have you. And if you have that balloon, listen to this trick. If you have that balloon and you place it next to like a empty can Coke, an aluminum can, you see the can moving for itself. So it's got a nice trick to show kids and stuff. If you have a birthday party, you can tell them it can make this can move for itself. Right? But what is actually happening there? The electrons in the balloon is actually, like repelling the electrons from the can, which is going to cause the can to move. Anyway, the point there is that your clothes or the can or the balloon is building up electrons, right? And that's why it's said to be static because it's not going anywhere. That is kind of hazardous if you all think about those of us in the companies, if you have like a diesel storage tank, right? And workers are coming to this diesel storage tank to withdraw but diesel, of course, right? But the workers are standing next to the tank, they're rubbing up on the tank. That could actually result in static electricity building up on their coverall. And they say just a spark, if this is diesel, could cause a fire. So what they do, for those of us who know, you can actually try to discharge these things from your clothes, right? One of the way is like making contact with the ground. Yes, electrons are attracted to the ground. The ground, the earth that we are on, is positively charged. The earth that we are on is positively charged, right? You know what I saw? I saw there's a whole new science now. When I say new science, but probably new to me, where in terms of health, they are telling people, like to stand bare feet on the ground because it's good for you because like we pick up charges on people, right? Remember, like when somebody rub off on you physically and mentally, like we pick up charges on people. But if you never make contact with the ground, which is actually scientific, like you would never really discharge that from you then, right? So I was seeing that you can check this out on Amazon. They actually have earth mats. Yeah, an earth mat, like for people who live in apartments and stuff. So it's an earth mat because the mat is positively charged. So like if you're doing your exercises, whatever you do, you could stand on this mat. It's called an earth mat, and the mat is actually positively charged. So instead of standing in the ground, I guess people who live in apartments and whatever have you, right? You can do that. But the whole thing there, the whole science is that static electricity is current that builds up. How they do it with the diesel tank is that they'll have like a wire going to the ground. So if there's any charges that this worker here would have built up on the tank, the charge will get to the ground then, right? But naturally speaking, if it didn't have the wire and you didn't really stand on like you didn't really stand on the ground with your feet, the charges is building up on you. So maybe that's why everybody's so stressed or whatever have, right? Maybe we need to discharge some stress a bit, right? Because this is actually true for nature, it's also true. Like, it's true for a balloon, it's true for human beings and whatever have you, right? That there's a whole health thing now about, getting people to sort of make back contact with the earth anyway and the ground in that sense, right? What do you all think about that? I think it's interesting. I haven't done it. I just telling you, I think it's interesting, right? That's what static electricity is anyway, right? It's charges that build up. So that's why I see here grounding. So that's why I have grounding and bonding. Bonding at this stage could be thought of as grounding as well, but it's actually not. Bonding is like when you connect like a wire between vessels, like if you think about tanks, and that wire is now sent to like a positive charge or maybe back to the earth. So it's kind of like grounding, but bonding actually really means like you connect the tanks with like you run a wire between them there. Could be like a ground wire, right? So it's bonding because you're kind of wrapping those tanks. You're not physically wrapping it with wire, but you may have a cord, like a earth wire from one tank to another tank. Let me try to draw what I tried to talk about, right? So you can see it, right? So if you have three tanks, right? These could be bonded together. It's not a physical wire. You'd see the wire could be buried in the ground, but the wire is connecting these three tanks here. So the wire is actually bonding the three tanks. So hence it's called bonding, right? And of course, this is actually goes to the ground because that's the only way to release electrons anyway, right? Electrons are attracted to the ground. The ground is positive. That's the only way to discharge any buildup of charges on these tanks. Think about if these tanks were used in the aviation industry for, the airline industry. So you'll have to kind of get rid of any static charge because the slightest charge and the slightest charge would create a spark, could result in a massive fire anyway, right? All right, that's done. Let's try to move on a bit. So planning for power outages, I could just tell you what the slide is. The plan for power outages is to have like a backup generator. That is referred to as an uninterruptible power supply. That's what you see here. This kind of talks about how those generators or UPS work. They work like your cell phones, I guess, to be honest, right? So you plug it on, the AC current is going to go to charge a battery. When you use your device, the current is used from the battery then, right? It could be converted back from AC to DC, sorry, from DC to AC. I don't think this kind of level of physics is needed, right? But we could talk about the safety part of it. So the uninterruptible power system offers the advantage of supplying power to the load continuously, no matter what happens to the utility power. The process of taking alternating current from the utility and converting it to direct current and then back to alternating current eliminates practically all power disturbances, including transient noise and voltage fluctuation, right? You have different portable devices or large devices that do these things anyway. There's a device called an inverter. You can get it. Look, I have one here. Those of us who did process safety, I guess, I'm not too sure if I showed you mine. I had gotten two from Amazon. I don't know if they're available anymore, but very small devices about the size of what you're looking at here, but more digital. The long and short is that they remain plugged on in the event of power. You could actually it remain plugged on because it's charging. But in the event of a power supply, I could plug into my inverter, and then the inverter now would now take the power from the battery, convert it back to AC, and I get power to run my fans and my television and whatever have you from a very small inverter. I think I'd shown, and this ever shown the class, but I have two at home. You actually have one that connects to like a car or a van or a truck battery. That's a cheaper one. You can probably get that for around less than 1,000 TT. We can get that probably from most hardwares. You can get, a portable inverter. A lot of people who go camping and stuff, they use it, but they could use it for power outages, I guess, in Guyana and Trinidad as well. All right, dangerous substances. You have a law for this, a dangerous substance. One of the laws is the Dangerous Substance and Explosive Atmospheres Regulation 2002. It defines what is an explosive substance, what is an oxidizing substance, what is extremely flammable, what is highly flammable, what is flammable. These may be that you have to learn them when we get to them, right? Yes, I know I showed the class, but I'm not home at the moment. I don't have any of them at the office here, right? But they're very, if you, Amazon, as soon as it comes, it sells out on Amazon. But it's nice for emergencies then, right? If you don't want to use a full-fledged generator, there are some people that, like me, who don't believe in a full-fledged generator because it does create, like extra or additional carbon dioxide. If you have like small kids and stuff, you probably don't want like a generator because it carbon dioxide, carbon monoxide, is odorless and colorless. So like for those who use those devices, there are many cases in the States and in England and stuff where people fall asleep and they just don't wake up. There was one actually in Guyana, right? There was one in Guyana when I was across there with the vehicle that was stuck in the mud. And of course, they left the engine running with some kids and stuff, and the carbon monoxide came back, put them to sleep, and they just don't get up, right? So for that reason, if you don't like the generator either, because it does create the same carbon monoxide that's in your exhaust of your vehicle, you can think about a generator. You can think about the one from the trucks or the cars or whatever. They are much safer. It doesn't have any gases involved in them anyway, right? Of course, Trinidad and Guyana kind of lucky. Well, I would say lucky. I wouldn't say kind of lucky. Trinidad and Guyana, like more or less, like we are not in the hurricane belt. Stuff normally pass Trinidad and go up, and of course, Guyana is on that side, so it doesn't even go to Guyana at all, right? But like we are kind of lucky that we don't have so much of power outages. You can actually check in Trinidad how much times it have flood for the year. You can actually check it on one hand, right? Normally, you look at around November month, June month, a bit in October. The rest of the months are pretty dry. Guyana, of course, is dry as well, like in November, October. They're not in the hurricane belt at all anyway, right? So, I guess of course Guyana does have some power outages, but you can think about these things for your use anyway. Anyway, back to this, right? I was saying you may need to learn these definitions, right? So what is a dangerous substance? probably not this one, because this is still saying what is a dangerous substance, right? I was talking about these here now. What is a flammable substance? What is an oxidizer, right? But for now, still the law is still saying what a dangerous substance is. So substance is a preparation which, because of its chemical properties, the way it is used or presence in the workplace, creates a risk of explosion or fire. Still, the law is saying what is a dangerous substance. Any dust, either particle or fibrous or otherwise, which can form an explosive mixture with air or an explosive mixture. This acronym here, I don't know if you want to take it down as yet. This is it. This is the acronym for law. And the law is the control, if anybody writing it, the control of major accident hazard regulation 2015, right? And that law also classified what is a toxic substance. You would need to learn some of these definitions, right? Whether or not you learn it now or coming closer to the end of the course, it'll be best to learn it to the end because you'll forget, right? Toxic, oxidizing, explosive, flammable, highly flammable, extremely flammable, dangerous to the environment. For those who did process safety too, that same law, COMA, required the employer to zone the areas. This is a nice question, where a worker may be exposed to I guess a flammable gas or a hazardous gas or dust, right? And what they did, the zoning system, well, they have two zoning systems, right? So the other one is on the other slide. So just bear with me a bit, right? You have two zoning systems. You have for gases. The law, if you look there, COMA is saying that the employer needs to zone the area as three zones, zone 0, 1, and 2. And then if it is a dusty environment that you are in, like a flour mill, you need to zone the atmosphere to as zones 20, 21, and 22, right? This is a nice question to come, they can say like, like what is the zone classification for gases? What it is for dust? Zone 0 or 20 means that you are present in the atmosphere where that condition is there, right? So like if you are in a gas facility, as we have in Trinidad, or you are in an iron plant, or you are in a flour mill, and you are right where the mill is working, you are there where the flour is being fed into the conveyor, you are in a zone 20 if it's dust. Well, flour now, right? If you're in the office in that flour mill, which they have a lot green in Guyana as well, we have in Trinidad too, right? If you're in the office, well away from where the mills are at and where the loading and conveyors are, you could be said to be in a zone 22 atmosphere, right? For gases, though, again, Trinidad may be more relevant to this one. For example, we have a huge amount of, ammonia here. So if you're in the ammonia plant, right, you're in one of the Proman facilities then, right? Well, you could say if you are where it is at, where the gases are, being, condensed and whatever, how you can say you are working in a zone 0 atmosphere. Again, if you're high up in another facility, you're high up in a building somewhere well away from that, you could be said you're in the atmosphere because the gas is there, but, it's unlikely to occur. Explosive atmosphere is unlikely to occur. You're in a zone 2 atmosphere anyway, right? So just in case you didn't get that, please take this down. I'll leave it here because this is something you have to learn. Some of us know it already, which is good. Let me get this slide to go. 2021, 22 is dust. Look at right here. 2021, 20, you are present in the dusty environment. 21, you're likely to be exposed to a flammable atmosphere, explosive atmosphere. 22, you're in the office. You're far away from the building. The building is probably, like, yes, I guess some facilities are huge, or even you're across the road, right? You're across the road in another facility, right? Now the atmosphere is there because the concentration of dust or gas is there, but it's unlikely to occur then because you are not in that atmosphere anyway, right? Tell me if you're okay with this. I can see a nice short question. We're going to have to pause a little bit. We paused a little bit already, but I can't pause on every single thing. I know that this is a nice question though, right? We did see one question for the evening already. I can't pause again because look at the time. If there's one, we'll kind of just pause a bit and look at it, right? If not, what I want to do from probably Sunday, I want to open one of the past papers, right? The questions I've shown you, they are all from past papers, but it'd be nice to kind of open it at the same time, right? We could skip this. This is like one of the questions on process safety. Which of the following is zone 1? Zone 1 is a place in which an explosive atmosphere in the form of a cloud of combustible gas in air is likely to occur in normal operations occasionally, right? So this is answer there would have been B for that one. But for this exam, it's not like multiple choice. You have to explain yourself. You'd have to say like a zone 1 is where the gas is likely to occur. If they give you like a little passage, which they don't already do in this exam, you could probably make up an example and say maybe there's a gas plant and a worker is working next to where the gas is being refueled or condensed, and therefore he's in a zone. Well, actually, no, if he in it is zone 0. But based on this question, if it's zone 1, you'll have to say that he's likely to be around the facility, so maybe he's in a zone 1. If we stick to this, but I don't have to stick to this. I'm just saying, different scenarios or different participants could ask different things anyway, right? And you have to know them, right? So reaction hazards, effects of temperature and pressure. So reaction rate is exponential to temperature and increased by a factor of 2 for every 10-degree rise. Cooling rate is linear to the rate of reaction. Exothermic chemical reactions are those that give out heat energy. That's a nice definition. In this exam, they could ask what's an exothermic reaction. Endothermic reactions are those that absorb heat energy. It is essential to maintain the reaction temperature within a narrow band to prevent an uncontrollable or runaway condition occurring. Effects of pressure, the effects of pressure and temperature is the same, just in case. So if the rate of reaction increases with temperature, the rate of reaction also increases with pressure, right? It's said to be a proportional effect. Temperature and pressure have the same effect on the rate of reaction. So we can leave this one out. You can read it out. What is meant by the term exothermic reaction? What is meant by the term endothermic reaction? What is the flash point of a liquid? That is some Sunday class. The answer is right here. Who plays the drums in the Muppet Show? Anybody remember the answer for the last one? Okay, you might remember the answer for the third one. Who plays the drums in the Muppet Show? Nobody? Anybody know what the Muppet Show is? This generation might know what the Muppet Show is anyway. All right, so what is a catalyst? A catalyst, this again is a nice definition. The thing about this exam is nice short questions, right? So that's the catch though. You have to learn things if you don't know it. So a catalyst is a substance which will promote or retard a chemical reaction, but are not affected or consumed by the chemical reaction. They provide a lower route for the reaction to proceed, or a lower temperature route for the reaction to proceed at the electron transfer level, right? Here we have how they make margarine butter. They take castor oil and, of course, hydrogen. It's under a specific temperature and pressure. And they use a catalyst, platinum catalyst. The platinum catalyst does not affect the butter in any way, or the taste of the butter. That's what the catalyst does. What the catalyst does, it speeds up the reaction. So you get your product, the castor oil and the hydrogen, comes together, creates that creamy margarine, but in a faster way for the industries then, right? And of course, the catalyst is just, I don't know if you know what, it's like in a different vessel altogether as well. Speeds up the reaction, but doesn't interfere with the reaction itself. So a nice definition there. Good. Animal plays the drums on the Muppet Show. That's exactly correct. Hopefully nobody had to Google that. Hopefully you just had to remember that, right? I think recently somebody was telling me that Big Bird, and this is the most ridiculous thing to talk about, right? Because it's class, right? But somebody was saying Big Bird have I ever gotten the impression that Big Bird was like a female? I never even thought about it. I always thought Big Bird was a male. Anybody? I thought Big Bird was a male. I think he's a male. Anyway, I saw somebody arguing that, right? I guess those of us who may be around that Sesame Street time anyway, right? But to me, Big Bird is a male because isn't he friends with, I think, the elephant? I always thought he was a male. I don't know how people are redefining these things now anyway. All right, this is what a catalyst does. It lowers the energy needed for a reaction to occur so you can get your product faster, quicker, with less energy, less consumption, less heat, whatever have you that is needed for that reaction to occur, right? Thermal runaway reaction. This is really easy for me, right? But let me just read it out a bit. So for those who may not know it, so thermal runaway reaction refers to a situation where an increase in temperature changes the condition in a way that causes a further increase in temperature, often leading to destructive results. The term thermal runaway is used whenever a process is accelerated by increasing temperature, in turn releasing energy that further increases temperature, mainly associated with exothermic reactions. The simplest way to think of a thermal runaway reaction is like a car going down a hill. You don't really need any more fuel. So that's like a thermal runaway reaction. A thermal runaway reaction is like, I guess if I'm trying to think of some simple examples, right? Like if you're heating a vessel, like maybe a pot on your stove and it starts to overflow. The thing is, the overflow will continue because it got enough heat already. Even if you probably turn off your burner, there'll be a certain degree of overflow, right? So thermal, that's why it's called a runaway reaction. Is like if you stop the energy supply, it's still going there, right? And so like there's some ways you can deal with it. Like you'll have to dump it, you'll have to rapidly cool it because it's called thermal. It has gotten like a lot of heat then. A bad example of this, I say a bad example, is the propane tank at home. Like if your propane tank was involved in a fire, which God forbid, but let's say the tank didn't explode, right? So you saw a fire was at the top of your propane tank. The tank has, I mean, like the tank is hot, right? So what's happening is that you have gases would be sort of relieving from the tank because the tank have like a relief valve, right? So what you're gonna have to do, you're gonna have to cool that tank by throwing water on it then, right? So one of the ways, if you look here, one of the ways of dealing with it is actually cooling. You see it here, crash cooling, because it's thermal, it's heat, right? Some of the causes of a runaway reaction, management failure, lack of organized operating procedures, 77% of thermal runaway reactions occur like that. Poor maintenance, lack of supervision, failure to communicate properly, defective components. You have others like human error, right? The causes of a thermal runaway reaction is never good. Loss from fire, loss of containment, explosion, the whole list, right? The whole list of bad things. Lost production, loss of life, lost reputation, prosecutions, enforcement, civil claims, lost clients, the list goes on and on, right? So how do you deal with it? You can actually contain well, you could contain if you have something called a blowdown drum, right? A blowdown drum is if your vessel is overheated, you have something to pump it to then. Blowdown drums or isolation chambers come equipped with that or for that. So if you dump your reactor contents in them, they will neutralize it, right? Crash cooling, if you have maybe some sort of suppressant, some kind of nitrogen gas supplied as a, like meant for such emergencies, you could actually use the nitrogen gas and cool it, right? Drowning and quenching the reactor's contents as long as it's not reactive with water. Emergency venting, dumping of reactants, example, the scrubber system, knockout drums, and flare stacks where possible, right? All right, we almost finished. What do I think? It's just 7:10. I could just explain these. We can finish, right? I could explain these a bit. Let me just explain them because reading it, I'll read one or two and then I'll move on, right? So here we have bulk storage operation. So again, we can say that these are regulated by laws around the world. Hazards of any tank, you have overfilling, effects of vacuum. We kind of discussed that already. Overloading of the foundation. If your foundation isn't steady enough, maybe you have an old foundation, you put in a new tank on that, right? Creep, which is how we said that from years of use, tanks are welded on together. It's not just one sheet of metal, it's welded, right? So if you have corrosion, you empty the tank, you fill the tank, you empty the tank, you fill the tank. It will cause the metal to sort of expand and contract a bit. If a vehicle came by, struck the tank, a contractor reversed a van onto it, all of these things then, right? You have thermal shock, brittle fracture. Brittle fracture is if you have, I guess, oil or even diesel or gasoline in a tank, those fluid tends to be warmed then by nature. So if you withdraw that fuel and then you hydrostatic test your tank with water, it's going to cause a difference in temperature to the tank material itself. These things can fail. They have failed, as I mentioned before, when they are put under hydrostatic testing, right? Siting of tanks, just keep them away from each other too much. Make sure tanks have proper drainage around them to protect from flooding. Fire protection tanks are normally rooted to the ground. You normally have like extinguishers on a tank location. Anybody, working in and around them must be trained, supervised, have proper permission to be there. Lightning, most tanks again have like a lightning rod, right? You don't want to be storing aviation fluid and then, a lightning strikes onto the tank, right? Must be properly inspected, segregated from other tanks. There's like a minimum distance then, right? 2 meters. In fact, no, it's actually 10 meters, right? If you read through this a bit, it's actually 10 meters, the distance from one tank to another tank, right? Like the least distance must not be less than 10 meters anyway between tanks anyway, right? Sighting of tanks, let me see. Let's go back here a bit, right? Sighting of tanks, we read that one. Consider a good base, impervious hard standing ground, have firefighting measures in place like a deluge system, emergency response plan, emergency trained staff, spillage control and bonding. Hold the least you could in the tanks if possible. Maintain a distance away from people, minimum 10 meters anyway. Distance from other tanks containing what substance, if it is a dangerous substance inside of it. Ventilation requirement for certain types of tanks, right? So filling of tanks, measures must be in place to prevent overfilling, can include alarms, tanker connection to a bleed, which is when the tank reaches a certain level, it flows into another tank. Bonded areas must be able to hold 110% capacity of your tank or all the volume of your tank. I don't have time to discuss all of this now, but logically, if you think about it, no bond could ever do that. No pit could ever hold all the contents of your tank. So what they do, they have a series of pits, for those who know what they do, right? They have not one pit, but a series of pits, right? Sometimes they call it like a dike or oil catchment. You can have about 5 pits in one area, right? So that's how they do it. It may look like one pit, but if you look inside of it, you would see like a Jack Spanier nest then. You will see like there are lots of pits inside of that one pit anyway. That's one way of doing it. And each pit with different depth and size. And when one pit fills, it flows or bleeds into another pit, etc., etc. That's about the only way to get a bond big enough to hold. Folks, watch how big a tank can be if you know what tank farm is. There's no bond that can hold all the fuel inside it. And there's no one pit, but there's a series of pits that can do it, not just one pit anyway. All right, that's not a question, that's just reality, right? So you have different types of tanks. We have fixed roof tanks, open external floating roof tanks, dome external floating roof tanks. Fixed roof tanks are vertical steel cylinders with a permanent attached roof in the petroleum and petrochemical industry. These permanent roofs are usually cone shaped, well, just like that, right? And sometimes referred to as a fixed cone roof tank, right? Let me just explain the rest of them, or are they here, right? We have internal covered floating roof tanks have a permanent fixed roof with a floating roof inside. Internal floating roof tanks usually have vertical supports. Okay, so I could show you a picture of this, I guess, or draw one for you. This is one right here. This is an internal floating roof tank. Well, for those of us who are looking at it for the first time, because we covered a bit of this in process safety as well, the tank have 2 roofs on it then. It's not just one. You have a fixed roof here, and you have something floating on the level of the fuel. This is an internal floating roof tank. So it has 2 roofs then. One of the roof rises and falls with the fuel level. For those who don't know the purpose of that, it reduces the headspace. The headspace is like wherever you have a space of oxygen. And if you know about fires like oxygen. So if you just had like a fixed roof like that, forgive the bad drawing of the tank, you can have a headspace that the tank will never be filled like up here. The tank will be filled here. And then all of this now is oxygen. But for fire to start, you need oxygen. So what they do with the aviation fuel industry then, and what they do, they have like another roof on the fluid level that cuts off the headspace so that if there's oxygen here, well, this roof takes care of that then. It's not allowing the oxygen to get in contact with the fuel level, right? It's called an internal floating roof tank because this roof is inside of the other roof then, internal floating roof, right? However, there's another type of tank, which we're going to have a look at now. If I could get this slide to move, it's called an external floating roof tank. most of the questions have come on this. This tank doesn't have a fixed roof. The roof that was here is also the fixed roof, right? The internal roof then, if there's no external roof, becomes an external floating roof tank, right? There's no fixed roof on top of this one. This does have additional hazards like like rain, storm, hurricane. You do have, if you read through this, you have platoons, which is where the waters could drain off. This will actually connect and connect to the base of the tank and run off. That system that they place in it then is able to run off the water as well. But the platoons, if you're watching here, let me just try to bring this up a bit bigger. They are very small holes. I mean, when I would say very small, I mean, looking at it, drain, it looks big. But if there is like a thunderstorm then, right? Or a freak storm, you know what would happen. The best drain you have, just look around Trinidad, look around Guyana, the best clean drain you have, if there is, like a certain 2-day rainfall in 1 hour, it's going to flood, right? So these things have happened. And what normally happens with these, the main hazards is that this roof, once it start to become unstable, like piece of it start to sink, the whole thing will sink. It's kind of like the Titanic. Once this side start to sink, the whole thing will just keep going on. We'll just soak up with water and sink, right? So external roof, floating roof have the advantage of cutting out the headspace. But if you don't have a fixed roof on this could be subjected to elements of the weather. You may want to have, I mean, it's not practical to put a shed over these things. So, it's not practical because remember, these things represent tank farms, which are huge tank facilities. That's a tank farm. You have something called a tank battery. A tank battery is just like 1 or 2 tanks. A tank farm is a collection of tanks, right? Thank God we've seen all fixed roofs here, again, from the pit here anyway. That's the sensible thing to do. Have the internal, floating roof tank, not the external floating roof tank. So I can read this one. External floating roof tanks, open top external floating roof tanks are vertical steel cylinders with a roof that floats on the surface of the liquid in the tank, but it is open to the atmosphere above. There is no fixed roof above. The only main difference between the internal covered floating roof tank and the open top external floating roof tank is the presence of the fixed roof above to protect it from the atmosphere. You also have different types as well. We spoke about bonding. Let me just take a look at the time. We already discussed bonding and how bonding can be done via a series of collection pits. And your bonded area must be large enough. The only way to do that, like I said, is a series of pits. Must be large enough to withstand or withhold then 110% of your tanks. If you work in the industry, you see how that is done? I would tell you it's by a series of pits, right? And when those pits fill, it actually goes into another pit. However, once those pits start to fill from experience, they will have contractors coming in with pumps and hose, and they will start up those hose and pumps and pump the oil if it is, like spill oil into awaiting trucks, awaiting tankers, right? It may get into another tanker, they filter it and then put it back into the tanks or whatever have you, the trucks have you. But it doesn't really overflow the next, unless if you have some kind of natural disaster like a storm or something happening anyway, then the contractors may have to wait until, the oil clear has been given in your country, then to see what's the impact of the oil. I worked at an oil catch location. I told you this before. Those of us who know me, I worked in the oil industry, in the early years. My father was a contractor. The monies and stuff I got to pay for my first degree was working in an oil catchment. A tank, series of pits. That's what I know what I'm talking about, right? And I spent months there, 6 months. In fact, I thought I was going to work my whole life there at one point in time because that's all I had known that working in the oil field, right? But I remember working there. There was like a storm. We couldn't do anything. Everything overflowed. All the pits overflowed, and they went into the beaches. You all must have heard about this. I suppose it's common in Trinidad. South Beaches, Coffee Beach, Labre Beach, those of us who know what I'm talking about. If you live in the southern side, you're talking about Lucero Beach and Erin Beach, right? Where in the event of a storm then, right, the pits are not able, when the river level rise and the pit level rise, you can't do nothing about that. You had to run because you will get flooded out. You have to abandon the position. But then all the oil makes it down to the fishing villages and stuff we have around Trinidad. You don't have too much of that in Guyana. But if there is some kind of flood or flooded area, you can just think about pits overflowing. And if it's high tide and massive, rain, you really no pit then made by man could withstand huge amount of flooding, right? So we would just watch the oil go because they couldn't do nothing. You just had to watch the oil from the pits, water level go, and it goes down into the river. And then you deal with that. The company at the time, Petrotin, would of course compensate the fishermen in the beaches. You almost want to talk about Coffee Beach, of us in Trinidad, Labre Beach, Erin Beach is a normal thing. These are normal things in the rainy season. Um, it's just there is no pit then, like I said, big enough to hold all the contents of a tank. There is no pit big enough. Then you have to make a pit big like a tank. Then the pit and the tank could be the same size, right? Okay, Alim has to go, right? We almost finished as well. I just trying to explain as much as I could here, right? So the purpose of bonding, we spoke about that as to contain the spill oil, right? Purpose of bonding, storage tanks, must be able to hold 110 capacity, which they do, but you can't really hold more than that in the event of a flood, right? 1.5 meters high is not high. That's why I say it's a series of pits. That's 1.5 meters is actually that's 2 meters or 6 feet. So this is less than 6 feet. That's less than the height of a door. A door is 7 feet. That's why you need a series of them, right? So what they could do, I think we could read out the rest. Or you could read out the rest. We mentioned hydrostatic test already. Maybe we could read these two here to close up the class, right? You can read out the rest. There isn't too much of questions on things like valve tested, right? But we did hydrostatic test. So let's read ultrasonic test. A technique for revealing flaws and defects in a material or device without damaging or destroying the metal. Using high frequency reflection or attenuation, cracks show up as an echo blip on the screen. Robotic application to test a tank, a camera mounted in a small magnetic robotic device. A drone could inspect the interior of a tank. This is above storage tank, ASTs, magnetic flux leakage. Flux leakage at a metal loss region is caused by a local decrease in the thickness of the pipe wall. A sensor position on the inside, the magnet side of the pipe is typically used to measure the magnetic field adjacent to the pipe wall. All right, so I'll advise you to read the rest. We have the hazards of lightning strike. We spoke about that already. Anyway, like the lightning rod. You can read out the rest. I don't see there's anything there difficult. Just read out the rest of it, right? So that will bring us to the end of class for tonight. Let me stop the recording. I do believe that Sunday we would be on our second